Eighth question is, a body of mass 5.0 kg, 5 kg is suspended by a spring which stretches 10 centimeter when the mass is attached. It is then displaced downward an additional 5 centimeter and released. Its position as a function of time is approximately. So here 4 alternatives are given. First one is y equal to 0.10 sin 9.9 t. Second, y is equal to 0.10 cos 9.9 t. Y is equal to third, y is equal to 0.1 cos 9.9 t plus 0.1, and y is equal to 0.05 cos 9.9 t. Now see here, y is equal to a sin omega t plus phi. This is equation of oscillations. Now here omega is not known, phi is not known, a is not known. What is given? A body of mass m is suspended by a spring which stretches 10 centimeter. Now we know omega is equal to under root k by m. K is force constant of the spring, but k is not given. So how can we obtain k to find omega? So suppose here this is spring. Suppose this is spring having force constant k. So force constant k. Now when we attach mass 5 kg to this spring, what happens? This spring, it is extended. So here we have attached mass. Now what is extension? Here extension is 10 centimeter. So here this one is 10 centimeter. 10 centimeter means 0.1 meter. 0.1 meter. And we know Hooke's law, F is equal to minus kx. F is equal to minus kx. So here, so magnitude is k is equal to f upon x. Now x is extension, that is 0.1 meter. 10 centimeter means 0.1 meter. But what is f? What is f? F is what? Now here due to mass, force will act, and that force it is in downward direction. So it is mg. So F is m into g. So we get here k is equal to mg upon x. So we get m is 5 kg into 9.8 meter per second square divided by 0.1. So we get here 5 into 98. 98, not 90, 900, it's 98. So it is your 490. And its unit is Newton per meter. K is equal to this. So we got K. We got K. So we can find omega now. So what is omega? Omega is equal to under root k by m. Now here it is 5 into 98 divided by 5. Mass is 5 kg. So we will get root of 98. So omega is root of 98. Means what is omega? Omega is equal to root of 2 into 49. So we'll get 40, root of 49 is 7. So 7 root 2. So this is 9.89 something. So this is approximately equal to 9.9. So we got omega is equal to 9.9 radians per second. Now next what is given? So when it is attached, 5 kg mass is attached, spring is stretches by 10 centimeter. So it comes here. So now this is your equilibrium position. So I can take this as x is equal to 0. It is then displaced downward an additional 5 centimeter. So here from its equilibrium position, the spring is again stretched by 5 centimeter and released. 5 centimeter means 0.05 meter and then released. So what happens here? It will oscillate between these two, 5 to 5. So x is equal to 0. So we can take here minus 5 centimeter. So amplitude is 5 centimeter, means 0.05 meter. This is amplitude. So we got amplitude, we got omega, and we require now what? Phi. So y is equal to, we got 0.05 sine 9.9 t plus phi. Now we want phi. So what is given? So at means here we take spring here and then release. So at t is equal to 0. So at t is equal to 0, what is y? Y is equal to a, means y is equal to 0.05 because it is released from extreme position. So we will put here 0.05 is equal to 0.05 sine. Now t is 0, so sine phi. So sine phi is equal to, now 0.05 divided by 0.05. So it is 1. So you will get phi is equal to what? Pi by 2. So we got phi is equal to pi by 2. So y is equal to now, so what is y? Y is equal to 0.05 sine 9.9 t plus pi by 2. Now sine theta plus pi by 2. It is sine theta cos pi by 2 plus cos theta into sine pi by 2. Sine pi by 2. So what happens here? Cos pi by 2 is 0. Sine pi by 2 is 1. So we get here cos theta. So what happens here? We get y is equal to 0.05 cos 9.9 t. So this is the equation of simple harmonic motion. So out of this last one is correct. This one is correct. Now we'll go to next one. If a simple harmonic oscillator has got displacement of 0.0 meter and acceleration equals to 2.0 meter per second square at any time, the angular velocity of the oscillator is equal to 10 radians per second, 0.1 radians per second, 100 radians per second, 1 radians per second. Now see, acceleration, it is minus omega square x in simple harmonic motion. So magnitude is A is equal to omega square x. Now here displacement at time t is this. So x is equal to 0.02 meter. And what is corresponding acceleration at that time? It is 2.0 meter per second square. So you will get 2.0 is equal to omega square into 0.02. So omega square is equal to 2 divided by 0.02. Now 2 divided by 0.02, we will get this one as 100. So omega square is 100. So omega is 10 radians per second. And now here we have to find angular frequency. So that is omega. So we get here 10 radians per second. So here first one is correct. First one is correct. So this is second multiple choice question. Now next one. A body is executing SHM, simple harmonic motion, when the displacements from the mean position are 4 centimeter and 5 centimeter, means we have two displacements. The corresponding velocities of the bodies are 10 centimeter per second and 8 centimeter per second respectively. The period of oscillation is A 5 seconds, B 3.14 seconds, C 2 seconds and D 6.28 seconds. Now see here, we have X is equal to A sin omega t plus phi, and we know oscillator, it is oscillating between plus A and minus A through 0. Now here velocity of oscillator is omega under root A square minus x square. So suppose this is first position, that is x1, and this is second position, that is x2. So when oscillator it is moving along this path, at x1 velocity will be v1 and at x2 velocity will be v2. So v1 will be equal to omega under root a square minus x1 square, and v2 will be omega under root a square minus x2 square. Now see here, 4 centimeter and 5 centimeter, these are positions, and 10 centimeter and 8 centimeter, these are velocities. So x1 is equal to 4 centimeter per second, corresponding velocity is 10 centimeter per second, x2 is 5 and v2 is 8 centimeter per second. So here, so we know x1, we know x2, we know v1, we know v2, and we know what is the period of oscillation. T is equal to 2 pi upon omega. So we have to find omega from this data. So here we have omega, is there, A is there, but A is unknown. So simply see, we can take V1 square minus V2 square. So square of first minus square of second. So we'll get here omega square a square minus x1 square minus omega square a square minus x2 square. So I have squared and subtracted. So I will get here v1 square minus v2 square is equal to omega square a square minus omega square x1 square minus omega square a square plus omega square x2 square. So these two will cancel. So we will get v1 square minus v2 square is equal to omega square, here omega square, in bracket x2 square minus x1 square. So see here now, so V1 square, V1 is 10, V1 square is 100 minus V2 square, V2 square, V2 is 8, so V2 square is 64 is equal to, now x2 square, that is 25 because x2 is 5, and x1 square, that is minus 60 because x1 is 4. So we'll get here this is multiplied by omega. So we get here 36 is equal to now 9 omega. So what is omega? 36 by 9. So that is 4. So we got omega is equal to 4. एक मिनट
omega square sir.
Sorry, here omega square. So omega square is 4. So omega is equal to 2. Now use here. So t is equal to 2 pi upon 2. So it is pi. Pi means 3.14 seconds. So we get here 3.14 seconds. So this one is correct. So while solving multiple choice questions, you have to remember all formulations in oscillations like displacement, velocity, acceleration, and so on. Now next one, two springs of constants K1 and K2 are equal maximum velocities when execute simple harmonic motions. The ratio of their amplitudes, and in bracket it is given masses are equal, will be K1 upon K2, K2 upon K1, K1 upon K2 bracket raised to 1 half, K2 upon K1 bracket raised to 1 half. So we have here two springs. First spring having spring constant K1, second spring has spring constant K2. Here we have to put have equal maximum velocities when executing simple harmonic motion, the ratio of their amplitudes. So here we have first spring, we have attached mass M, and this mass is oscillating about equilibrium position. Its spring constant is K1. Then we have another spring, may be different than first spring, and same mass is attached, and it is oscillating about this equilibrium position. Now we know x is equal to a sin omega t plus phi. This is general equation, and velocity is omega under root a square minus x square. And what is V max? V max, it is equal to omega into a, we know this, at x is equal to 0. So we have two springs. Now V max is equal to, we can write under root k by m multiplied by a. Now what is given? Maximum velocities are equal. So we can take V max 1, it is equal to root of K1 by M into A1 I can take, and V max 2 for second spring, it is root of K2 upon A multiplied by K2 upon M multiplied by A2. A1 and A2 are amplitudes. Now these two are equal. So we can write root of K1 by M into A1 will be equal to root of K2 by M into A2. So what is A1 upon A2? So we get here A1 upon A2 is equal to, now A2 is taken here, so you have to take this here. So we'll get here K2 upon M multiplied by M upon K1. So we'll get this as root of K2 upon K1. Means here K2 upon K1 raised to 1 half. So here last one is correct. This D is correct. This D is correct. Now we'll go to next one. A particle executes SHM with amplitude 0.5 centimeter and frequency 100 Hz. This maximum speed of the particle will be. Now we know V is equal to omega under root a square minus x square, and V max, that is maximum velocity, we get omega a, magnitude of maximum velocity. It can be plus or minus, whether it is moving along positive axis or negative axis, at x is equal to 0. Now what is given? Amplitude is 0.5 centimeter, frequency is 100 Hz. So amplitude we have here 0.5 centimeter means 0.5 divided by 100 meter. And what is omega? Omega, it is 2 pi nu, angular frequency. And we know this is 2 pi into 100. So what is V max? V max is omega is 2 pi into 100 and A is 0.5 upon 100. So we get here 100 get cancelled. 2 into 0.5 is 1. So it is pi meter per second. This is V max. This is V max. So here out of 4 alternatives, if we see A pi meter per second, so this one is correct. This one is correct. Now see next one. The maximum velocity and maximum acceleration of body moving in simple harmonic oscillator are 2 meter per second and 4 meter per second square. The angular velocity is, means omega is. Now we know acceleration in simple harmonic motion, it is minus omega square x, and velocity, that is omega under root a square minus x square. So V max is equal to omega into A. And what is A max? Means x is maximum. X is maximum means x is A. So we'll get here omega square into A. Now here V max is given and A max is given. So we get here what? 2 is equal to omega into A from this first equation. And from second equation, we get here 4 is equal to omega square into A. Now see here, I can write this 4 is equal to omega into omega A. And we know omega A is 2. So we'll get 4 is equal to 2 omega. So omega is equal to 2. That is in radians per second. And this is angular velocity. So here it is 2 radians per second. This is your answer. Now the unit of force constant is Now we know in simple harmonic motion, F is proportional to x and opposite in direction. So we know F is equal to minus kx. If we take magnitude, so F is equal to kx. So k is equal to F by x. Now F it is in Newton and x is in meter. So it is Newton per meter, that is unit of force constant. So Newton per meter, so this second one is correct. Here it is Newton meter, no. Newton per kg, no. Newton kg, no. Now we will get to next one. The maximum velocity of a body in SHM is 0.25 meter per second and maximum acceleration is 0.75 meter per second square. The period of SHM is pi by 3 second, pi by 2 second, 2 pi by 3 second and pi second. Now already we have seen here. Here we have seen. So Vmax is omega A max is omega square A. So here we know Vmax is equal to omega A max, maximum acceleration. It is omega square A is amplitude. So Vmax is given, that is 0.25 is equal to omega into A from first and 0.75 is equal to omega into omega square A from this second. So here now we can write 0.75 is equal to omega into omega A. So 0.75 into is equal to 0.25 into omega. So omega is 0.75 divided by 0.25, that is 3. Omega is 3. And now what is period? Period is t is equal to 2 pi upon omega. So we will get 2 pi by 3 seconds. So here out of 4 alternatives, first one is incorrect, second one is incorrect, third one is correct, and fourth one is incorrect. Fourth one is incorrect. Now we will go to next one. A body of mass 5 gram. So it is in CGS unit. Is executing SHM about a point O with amplitude 100 centimeter. If maximum velocity is 100 centimeter per second, its velocity will be 50 centimeter per second at a distance A 5, B 50 into root 2, C 50 into root 3, D 10 into root 3. Now see carefully. A body of mass M, mass 5g gram is executing SHM about a point O with amplitude 100 centimeter. So here we have body of mass M. Suppose it is oscillating between plus A and minus A. Here plus A, here minus A. So what happens? Its velocity is V is equal to omega under root A square minus X square. Now A is given, that is 100 centimeter. Now all quantities are in CGS unit. So solve in CGS unit, no problem. Now what is given? Vmax, maximum velocity is 100 centimeter per second. Now we know at equilibrium position we have Vmax and that is equal to A omega. And suppose we have distance x from equilibrium position. At that position velocity is 50 centimeter per second. We have to find that x. So we know Vmax is given. What is Vmax? That is 100 centimeter per second. So Vmax, that is A omega, is equal to 100 centimeter per second. That is given. And V is equal to this. V is equal to this. Amplitude is also 100 centimeter. So we can have 100 omega is equal to 100. So we'll get omega is equal to 1 radians per second. So we got omega. Now use this equation. So we have 50 is equal to omega into a square is 100 square minus x square, and omega is 1. So you'll get 50 is equal to this 50 is equal to 100 square minus x square. So here 50 square is equal to 100 square minus x square. So we will get x square is equal to 100 square minus 50 square. Now see here, 100 square minus 50 square, you can write 100 minus 50 into 100 plus 50. We know x minus y into x plus y, that is x square minus y square. So we get here, this is 50 and this is 150 into 150. So we can write this as 50 into 50 into 3. So we get this is x square. So x is equal to 50 into 50, that is 50 square. So we'll get 50 and square root of 3 is root 3. So x is equal to 50 into root 3. So here third one is correct. Third one is correct. Is it clear to you?
Yes, sir. Oh, sir.
Yeah. Okay. Now we'll go to next one. Now see here. The time period and amplitude of pendulum are 4 seconds and 0.2 meter respectively. Means time period, that is 4 seconds, amplitude, that is 0.2 meter. If the displacement is 0.1 meter at time t is equal to 0, the equation of its displacement is represented by. So we know here I have taken y, so you can take x also. So here y is equal to, equation is same, only along y axis, a sin omega t plus phi. So we have to write equation like this. So we have to find a, omega and phi. These three quantities we have to find. Now it is given, time period and amplitude is given. So amplitude is what? A is equal to 0.2 meter. T is given. T is what? 4 seconds. So, and we know T is equal to 2 pi upon omega. So omega is 2 pi upon T. So we get here 2 pi upon 4, that is pi by 2. Pi by 2 radians per second. So we got omega also. So we get here y is equal to 0.2 sin omega is pi by 2 into t plus phi. Okay, so we got this. Now we have to find phi. How can we find phi? So let us see this next one. This one. if the displacement is 0.1 meter at t is equal to 0. So we have already got equation. So at t is equal to 0, what is y? Y is 0.1 meter. So put here. So 0.1 meter is equal to 0.02, that is also in meter, sine pi by 2 into 0 plus phi. Now if we take here, so we'll get sine phi. This is 0. So sine phi is equal to 0.1 divided by 0.2. So this is 1/2. So sine phi is what? Sine inverse 1/2. Now what is sine inverse 1/2? Ankaja, what is sine inverse 1/2?
Pi by 6, sir.
It is pi by 6, 30 degree. So it is pi by 6. So we got phi also. So use here now. So we'll get y is equal to 0.2 sine pi by 2 into t plus pi by 6. Pi by 2 means you can write 0.5 t. So here this one is correct. See, y is equal to 0.2 sine 0.5 t means pi by 2 t plus pi by 6. Now we'll take next one. A particle executes SHM. Its velocities are v1 and v2 at displacements x1 and x2 from mean positions respectively. The frequency of oscillation will be. Now we know angular frequency is omega, that is 2 pi nu. So nu is equal to omega upon 2 pi. We must know this. Now what happens here? So this is path of oscillation. So plus A, minus A, and here equilibrium position. And v1 and v2 are velocities at x1 and x2. So you can take here first position x1 from equilibrium position, second position x2 from equilibrium position. At x1 velocity will be v1, at x2 velocity will be v2. And we know general equation of velocity. V is equal to omega under root a square minus x square. This is general equation. So what is v1? v1 is omega under root a square minus x1 square. And v2 is equal to omega under root a square minus x2 square. So this is equation first, this is equation second. Now we have to determine omega to find nu. So here we have two equations. A is unknown. So you can eliminate A from these two equations. So how can we eliminate? Just square and subtract. So v1 square minus v2 square. So v1 square are this, that is omega square a square minus x1 square minus omega square in bracket a square minus x2 square. So we get here v1 square minus v2 square is equal to omega square a square minus omega square x1 square minus omega square a square minus plus omega square x2 square. Now these two will cancel. So we'll get v1 square minus v2 square is equal to, I can take omega square common. So x2 square minus x1 square. So omega square is equal to v1 square minus v2 square upon. Now here x2 square minus x1 square. So what is omega? omega is equal to square root of V1 square minus V2 square divided by x2 square minus x1 square. X2 square minus x1 square. So what is nu? Nu is omega upon 2 pi. So simply divide this by 2 pi. So you will get 1 upon 2 pi V1 square minus V2 square upon x2 square minus x1 square. So see here. Actually here it must be x2 minus x1. So this there is typing mistake. So this second one is correct. V1 square minus V2 square upon x2 square minus x1 square, square root of that multiplied by 1 upon 2 pi. Now we'll go to next one. A particle at the end of spring executes simple harmonic motion with period t1, while the corresponding period for another spring is t2. So we have two springs. If the period of oscillation is with two springs in series is t, comma then. So what is given here? Suppose we have first spring and suppose we attach mass m, k1. We know t1 is equal to 2 pi under root m by k1. We have another spring of spring constant k2. Then here period of oscillation t2 is equal to 2 pi under root m by k2, simply m by k2. Now what is given? T is period of oscillation when two springs are in series. Means here we have first spring and to that first spring we attach second spring, and then here mass m. So here k1, k2, and oscillate this. It will have some period. T is equal to 2 pi under root m by k. Then what is k here? What is k here? So we know when springs are oscillating, they are either they are storing energies. So they act like capacitor. So when two springs are in series, for springs in series, we have equation 1 upon k is equal to 1 upon k1 plus 1 upon k2. When two springs are in series, this is resultant force constant. So we have here T is equal to, you can write 2 pi under root, now here m, now 1 upon k. I can write 1 upon k as 1 upon k1 plus 1 upon k2. So we get here T is equal to, you can write 2 pi under root m upon k1 plus m upon k2. So square. So we will get T square is equal to 4 pi square m upon k1 plus 4 pi square m upon k2. Now see here, T1 square is 4 pi square m upon k1, T2 square is 4 pi square into m upon k2. So I can write T square is equal to T1 square plus T2 square. T1 square plus T2 square. So if we see here, Here second one is correct. Second one is correct. Now we'll go to next one. So same problem is given here. Means we have two springs separately, they will have periods of oscillations T1 and T2. Now they are connected in parallel. Means what happens here? Here this is first spring and this is second spring. And they are connected in parallel, and this is mass M. And it is oscillating about equilibrium position K1 and K2. When springs are in parallel, like capacitor for parallel springs. So K is equal to K1 plus K2. Now we know T1 is what? 2 pi under root M by K1. T2 is 2 pi into under root M by K2. And T is what? 2 pi under root M by K. So T is equal to 2 pi under root M upon K1 plus K2. Now we have to find whether this is correct, this is correct, this is correct, or this is correct. So let us take 1 upon T. So we'll get 1 upon T. It is 1 upon 2 pi under root K1 plus K2 upon M and square. So we'll get 1 upon T square is equal to 1 upon 4 pi square in bracket K1 plus K2 by M. So we get here 1 upon T square is equal to 1 upon 4 pi square K1 upon M plus 1 upon 4 pi square K2 upon M. Now see here, if we take this 1 upon T1 square is equal to 1 upon T1 is what? 1 upon 2 pi under root K1 by M. So we'll get here 1 upon 4 pi square K1 by M. Similarly for 1 upon T2 square. So 1 upon T square is equal to 1 upon T1 square plus 1 upon T2 square. So I can write T raised to minus 2 is equal to T1 raised to minus 2 plus T2 raised to minus 2. So here out of these 4, this last one is correct. Now next one is mass spring oscillating system undergoes SHM with maximum amplitude A. If the spring constant is doubled, what effect will it produce on the mechanical energy of the system? Now mechanical energy E is equal to 1/2 m omega square A square. And we know omega is under root K by M. So omega square is equal to K by M. So what is E? E is equal to 1/2. Now m omega square is equal to K. So we'll get K A square. Now see here, if the spring constant is doubled, means K is doubled, what will happen to mechanical energy? So when K is doubled, what happens? Make K 2 times. So I can write E1 is equal to 1/2 2 times K into A square. So we'll get 2 times 1/2 K A square. So we'll get 2 times E. So energy is doubled. So energy is increased by factor 2. Energy is increased by factor 2. Now next one. A mass M lying on a horizontal frictionless surface is connected to one end of a spring The other end of the spring is connected to all as shown in the figure. At t is equal to 0, the mass is given an impulse. Then, so this was asked in IIT JAM 2015. X is equal to x a sin omega t, v is equal to b cos omega t. V of t means at time t. Xt is equal to a sin omega t, v is equal to b sin omega t, xt is equal to a cos omega t, vt is equal to b sin omega t, xt is equal to a cos omega t, vt is equal to b cos omega t. Now see here, x is equal to, we know, a sin omega t plus phi. Now see here, when spring is at rest, means relaxed position, this is your equilibrium position, that is x is equal to 0, and impulse is given, means some impulse is given at that position, so it starts oscillating. So at t is equal to 0, what is x? X is equal to 0. So we get here 0 is equal to, now A, amplitude is A. So it can go up to A, minus A here, and up to plus A here. So it will oscillate between plus A and minus A, but it starts from x is equal to 0 at t is equal to 0. So we will get A sin phi because t is 0. So sin phi is 0 means phi is what? 0. Phi is 0. So we get here x is equal to a sin omega t. And what is velocity? Velocity, it is dx by dt. So we will get here a omega cos omega t. So you can write velocity is equal to some constant b into cos omega t. So b is velocity amplitude. So x is equal to a sin omega t, v is equal to b cos omega t. So x is equal to a sin omega t, v is equal to b cos omega t. This is first one. Now next one, a sin omega t, b sin omega t, no. Cos omega t, sin omega t, no. Cos omega t, no. So this first one is correct. First one is correct. It is obtained from our equation of motion. Now next one, a simple harmonic motion. In simple harmonic motion, the speed is greatest at the point in the cycle when the magnitude of acceleration is maximum, the displacement is maximum, the magnitude of acceleration is minimum, the potential energy is maximum. Now see here, when oscillator, it is oscillating between plus A and minus A through 0. Now V, we know it is omega under root A square minus x square, and acceleration it is minus omega square x. So in simple harmonic motion, the speed is greatest. Greatest means here at equilibrium position, and that is what? V is equal to A omega, plus or minus, means along positive or along negative. So what happens here? Displacement is minimum here, that is 0. And what is magnitude of acceleration? Magnitude of acceleration is omega square x. Now if we take acceleration here, magnitude, that is omega square A, here it is 0, here it is omega square A. Magnitude. Here it is, actually it is plus here, minus here, but we have to take magnitude. So if we see here out of this, and potential energy, it is 1/2 kx square. So when velocity is maximum, kinetic energy is minimum. So last one is not correct. The magnitude of acceleration is minimum. The displacement is maximum. The magnitude of acceleration is maximum. See here, acceleration is 0 here, that is minimum magnitude. Displacement is 0. So what happens? This third one is correct. because displacement is minimum, that is 0. So this is not correct. Acceleration maximum, this is not correct. They are maximum at extreme positions. And the potential energy maximum, this is also not correct because potential energy is also 0 when velocity is maximum. Now next one. A mass M attached to spring oscillates with period of 2 seconds. So here this is last question, then we'll stop. So here M spring. So here T is equal to 2 pi under root M by K. And this is 2 seconds. Here Kitty, a mass attached to spring oscillates with period equal of 2 seconds. If the mass is increased by 4 kg, the time increases by 1 second. Assuming that Hooke's law is obeyed, initial mass mh. So initial period is this. Now period is increased by 1 when mass is increased by 4. So use here. So T plus 1, same equation will be valid because Hooke's law is obeyed. So M plus increased mass is 4 divided by K. So here it is 3 now. 3 is equal to 2 pi under root M plus 4 by K. So we have two equations. 2 is equal to 2 pi under root M by K. This is first equation and this is second equation. So simply square and take ratio. So square of first, that is 4, is equal to 4 pi square M by K, and 3, that is 9, is equal to 4 pi square M plus 4 by K, and then divide. So you will get here 4 by 9 is equal to, now see here 4 pi square will cancel, and kk will also cancel. So you will get M upon M plus 4. So here you will get 4 into M plus 4 is equal to 9M. So 4M plus 16 is equal to 9M. So here 16 is equal to 9 minus 4M. So we'll get here 9 minus 4, that is 5U. So 5M is equal to 16. So what is M? M is equal to 16 by 5U. So 16 by 5U, it comes out to be 3.2. So this first one is correct. First one is correct. So is it clear to you, everything?
Yes, sir.
Okay, Ankaja, Aniket?
Yes,
Oh,
sir.
sir.
Yeah. So now we'll stop here. In next lecture, we'll take composition of simple harmonic motion and angular SHM, and then multiple choice questions on that. Okay. So thanks here now. Okay, we'll stop here.